BIC or AIC, it's going to tell me the best model that I have to forecast out of the three that I've picked to look at. So we'll run those three. We get all this stuff. And these are all results, okay? For the models, okay? And so if I go back and look at my three specifications here, that I have run. Here's the first one, which is this a real model with an AR1. What I want you to notice as I run through these is not the values that go through themselves. You can go back and look for those. What I'm looking at is my AIC and BIC values again. Okay. Note that I've got an AIC here of 154, a BIC of 164. Remember, that's our Schwarz spreadsheet. Right? My second model is the AR2.
So this is all just telling you what form of the dependent variable you should be using.
What?
Or this
what component part? What order of the AR I'm going to run here? So what I'm going to specify my AR IMA model to be. Okay. That's the second one, and then. The third one is my difference, and it looks like that might be the best forecasting model, okay, because my ASC and BIC are the smallest. Okay, so it appears that by taking a difference and then running an AR model on the difference, it appears to be what might be my best forecasting model of the three that I've chosen to look at. Okay, but let's go back and look at them just to see.
You can take multiple differences too.
Sure. Yeah, I could.
Right.
You know, that D command that I had, I can run the once I have that difference command already put in there, I can do the second difference, a third difference, whatever I might want to do. Exactly.
But at this point, you haven't incorporated any other variables besides.
Nope. I'm just doing a univariate one forecasting. Just trying to forecast unemployment and nothing else is all I'm doing. Because again, that's kind of the first step. Before you sort of jump to doing a vector autoregressive model, which now is going to incorporate a number of variables which could be co-integrated, you want to look at the individual variables first before you sort of do more complex models. So it's like you got to be able to walk before you run in some sense. Does that kind of make sense?
Mm-hmm.
So would you do this for every single variable?
You could, yeah, you can. You can go back and do it for any variable that you want to forecast overall. Okay. So in this case, I'm just forecasting unemployment. So let's do the forecast real quick, and then we have to end here. So again, I'm going to retain the residuals. I'm going to look at those also and also do a Durban-Watson test. These are just my residuals themselves. Again, sort of centered around 0. So as Heidi was talking about, looks like we do have some outliers out here, okay, to worry about. And again, these are my residuals again over time, and you notice that they jump around a lot, okay. But they're jumping around a lot around 0. Okay, so that means to me that I probably have a reasonably stationary time series, which I like. Now I'm going to do a forecast here. And then I want to see what my forecast looks like. So I'm going to compare my forecast to the actual value of unemployment here. Okay? And this is the one step ahead forecast, but in sample. There you go.
Not a bad forecast.
It's a pretty darn good forecast, So I actually have the turning points almost exactly right. So the forecast is again the red line, the actual unemployment is the blue line, and in a very, very simple model, right, by just going back and specifying, looking at my two functions of my autocorrelation function and my partial autocorrelation function, doing my respective tests, figuring out which model sort of seems to fit the best. For about almost 50 years, I've done a pretty good job of forecasting unemployment. Right? So that kind of gives me some confidence in about predicting unemployment rates into the future using this very, very simple just AR1 model. But the idea is that if I would have done this and found out that my forecast was horrible, then I go back and say you've misspecified the model. So maybe I should include a difference term in this. Maybe I should have a moving average term in this. So I begin to build onto my sort of simple time series model by adding in more component parts to again improve my forecast. That's what I'm doing. And then if I think that multiple variables begin to influence this, then I can start to add more variables to either build a vector autoregressive model Or to begin to make the models even more complex, I can sort of have these error correction models that begin to take a number of other things into account. So heteroscedasticity, autocorrelation over time, okay? And so on, and so on, and so on. Okay. So the idea is that, again, simple models can forecast relatively well. So
Maybe you should quickly
we should probably
go
click here,
over
yeah.
maybe panel data, just quick exposition.
You guys have already, should I go through the panel data stuff or not?
Well, we went through this.
We pretty much went through that in class last time. That was like the last thing we covered,
I see,
sort of
okay.
in metrics one.
Okay.
So, but what I'll do is I'll post the data set for that. So again, if you want to go back through that, you can. I'll send you guys the data set for this. What I did show you was, I went ahead and actually did other forecasts on here as well. I'll do just one more real quick one. Here I actually went back and I did the forecast, but now using the difference as well. So forecast relatively well, but not quite as good. In the sense that with the differences here, because there are again some of those wide variations out there, the difference, even though it seemed to be the best model, doesn't seem to be forecasting as well as just the levels themselves. So again, I'm getting the turning points, but I'm sort of missing some of the spikes as well. And so, like Heider was saying, these are those outliers that the model's picking up, but it's not picking up the complete height of the spikes themselves. So again, it comes back to me and says, well, maybe I might want to go back and maybe do a second difference and see if maybe that second difference might improve my forecast overall. Okay?
So like an article we read for this week
Yeah.
specifically talked about outliers and specific diagnostic tests you could use, like
Yeah.
Cook's distance, like got some of these, the least trim squares and stuff like that.
Yeah.
Are these diagnostic tools you could use for time series?
Yes, same sort of
And
thing,
kind of
exactly.
correct for those sorts
Yeah.
of problems?
Try to correct for those sorts of problems. You know, I'm more cautious about sort of dropping them out because if they're actually in the data set itself, you know, it's an indicator of something that took place. But again, they're usually around some sort of unusual event. So in this case, if you sort of think about what these events are, if I were to overlay sort of economic downturns with this, or if it were to forecast GDP as well with this, then these tend to be periods where the economy is going down, right? Or periods of economic contractions. I won't use the R word there.
We also stopped in 2005.
Exactly, yeah. I did that first. I'm with this demonstrator, right? So
Yeah,
it got a little bit tougher to forecast from 07 to today,
yeah.
okay, overall. All right? Okay, so I think we better stop there, because otherwise we'll miss
Right. Well,
what I think.
thank you,
has to
Mark,
say.
and let's give you a round of applause.